Good day, dear students. My name is Isami Naura Maratqıza. I'm a teacher of English at Aqtoubia Higher Agricultural College. Today we have new theme. Our theme called Measuring Devices, ammeters and voltmeters. The aim of our lesson is to learn about voltmeters, devices that measure voltage, and ammeters, the device that measure current and their placement in electrical circuit. And for this, students, look at the screen. Now, today, students, we are going to speak about ammeters and voltmeters, what they measure, how to connect them, what is potential difference, and how energy is transferred. Current is the rate of flow of charge. Unit of current is ampere. Symbol of ampere is A. It's used to measure current. Here's an analogy we have used before. So we have got peas traveling around a pipe and there is a mouse in a treadmill. Now meters measure the rate of flows of charge, and using this example we are would have to count the amount of peas that pass a point every second. So we would place the ammeter just here so we can count the peas going past. In the same way, in an electrical circuit we place the ammeter in series, and we can literally count the amount of charge that passes a point every second. Using the electrical diagram, the ammeter must be placed in series. Now, try and think of it as the ammeter has to count the electrons that pass, so has to be placed in the way it doesn't matter where the ammeter goes as long as it's in the series. It could be on the left or in the right, at the top or at the bottom, or it doesn't matter as long as it's in series. Voltage is the energy per unit charge. It's measured in volts and we a voltmeter to measure it. Here's a diagram of a simple electrical circuit. Now the electrons come from the cell at the top. They travel down this wire through the bulb and then back up this wire back to the cell, where they can gain more energy and continue to go round the round circuit. The energy of the electrons at this point, just before the bulb, is quite high because it's just come from the cell. Then the energy is transferred light in the bulb, and then the energy of electrons after is slightly less because the energy has been transferred to light, and then the electrons carry back up the cell, where they gain more energy through the cell and then lose the energy through the bulb. What voltmeters do? They measure the difference in energy from the before and the after. That's why voltmeters must be measured in parallel. You must choose the component you want to measure. You connect one before and one later after. Then it's the difference that we are interested in, and this is called the potential difference. And that's the difference is energy from one side of the component to the other side, and potential difference is soft of a technical name of voltage. And lastly, students, I just wanted to describe the energy transfers that occur through a circuit, and just like I said before, on a simple diagram like this. The electrons gain energy for a cell, travel down this wire through the bulb, where the energy is transferred to electric heat and light energy, and then back up to this wire. And then they travel through the cell, where they gain more energy and continues to go round and round. So they gain energy through the cell and lose energy through the bulb. This is called work is done by electron on them on the bulb. It means that energy has been transferred. Now, dear students, our lesson is over. I think our lesson was very useful for you and interesting. Thank you for your attention. Goodbye.